Most people mistakenly believe that focus is something you're either born with or you're not, that it's a fixed trait like eye color or height set in stone by genetics or luck. But this idea is not only wrong, it's deeply limiting. Focus is not an inborn ability, it is a trainable neurological skill. It's a behavior that can be learned, rehearsed, and improved through consistent effort, much like building muscle or increasing flexibility. And like any skill that originates in the brain, it is governed by a series of biological mechanisms, neural circuits, chemical messengers, and plasticity pathways that can be tuned over time. Your ability to focus starts with how your brain assigns salience, a neurological signal that tells you what's important. At any given moment, millions of sensory inputs are bombarding your system. Sights, sounds, smells, internal thoughts, emotional states. The brain doesn't treat all of them equally. It filters and highlights certain inputs as more meaningful than others. That's what salience is. And the key point here is this: you can control what your brain labels as important simply by directing your attention with intention. This is the first step in training focus, to stop being a passive recipient of stimuli and start becoming an active manager of your attentional system. When you pick something to focus on and stay with it, whether it's a piece of writing, a workout, a conversation, you are sending a signal to your brain that this is the priority. Over time, your brain adapts by reinforcing the neural pathways that support sustained attention and suppress irrelevant distractions. The science behind this comes from studies of neuroplasticity, the brain's ability to rewire itself based on experience. Each time you focus on something for a prolonged period, specific networks in the prefrontal cortex and parietal lobes fire together in a synchronized rhythm. The more often you engage these networks, the more efficient they become. Synapses strengthen, neural pathways become more streamlined, and critically, your brain becomes more adept at filtering out the noise. People often complain that they're distracted, scattered, or unmotivated, but very few of them realize that distraction is not a failure of willpower. It's a learned state. Every time you allow your attention to fragment, whether it's checking your phone every 5 minutes or switching between tasks without finishing them, you are reinforcing the habit of mental fragmentation. You're teaching your brain that shallow focus is the norm. But the inverse is also true. When you create rituals and habits that reinforce deep focus, your brain learns that as well. Another crucial layer is the state of your nervous system. Focus doesn't happen in a vacuum. It requires a balance between alertness and calm. If your system is overly stressed, anxious, or fatigued, your ability to focus will collapse. That's why training focus isn't just about forcing your attention on something. It's about managing your internal physiological state. Practices like deliberate breathing, posture adjustment, light exposure, and sleep optimization all feed into your brain's ability to enter a focused state. They prepare the terrain for focus to take root. Importantly, training focus isn't about achieving superhuman concentration right away. It's about repetition. Frequency trumps duration. Even 60 seconds of deliberate focus on a single task, repeated several times a day, begins to reshape the neural circuits. Over time, this builds into minutes, then hours of focused work without mental fatigue. You're literally constructing a more attentive brain, one moment of focus at a time. This also means that comparing yourself to others is irrelevant. Some people may have naturally better attention spans due to their developmental environment or baseline neurochemistry, but no one is exempt from the rules of brain training. Everyone's brain can be reconditioned to increase focus if they understand the mechanisms and apply the correct protocols consistently. If you want to improve your ability to focus, you don't need to wait for motivation or rely on productivity hacks. You can start with one simple neuroscience-backed habit: visual anchoring. This is not some vague mindfulness exercise or philosophical idea. It's a practical and measurable behavior that taps directly into your nervous system's ability to shift into a state of deep focus. And what makes this habit so powerful is how it aligns with the biology of the visual system and its direct influence on the brain's attentional networks. The human visual system is not just for seeing, it is a dominant input channel that sends constant updates to the brain about your surroundings and where your attention should go. More than half of your brain's cortex is involved in processing visual information. This gives you a massive opportunity. By learning to control what your eyes focus on, you indirectly control your mental state. You can shift out of a distracted, anxious mode into a calm, locked-in state just by using your gaze. Visual anchoring works like this. You pick a fixed point in your visual field, a corner of your desk, the edge of your laptop screen, a mark on the wall, and you direct your gaze to that point for 30 to 60 seconds without moving your eyes. During this time, you don't let your eyes dart around. You don't look at anything else, and you don't close your eyes. You simply stare at that one point. It's deceptively simple, but this focused gaze triggers a cascade of neural activity. When you hold your gaze steady, something interesting happens. The movement parts of the brain, the oculomotor system, go quiet. Microsaccades, those tiny unconscious eye movements you normally make every few milliseconds, begin to slow down. This stillness sends a signal to your brain that the environment is safe and that you're preparing for concentrated effort. As a result, your body begins to reduce sympathetic arousal and your mind shifts toward a state that supports sustained attention. This behavior doesn't just calm your visual system, it also quiets the default mode network, a set of brain regions that tend to activate during mind wandering and self-referential thinking. By inhibiting this network, visual anchoring helps silence internal noise, looping thoughts, emotional distractions, unnecessary self-talk. What's left is an open channel for cognitive control. Your brain essentially starts prioritizing goal-directed attention because you've created the conditions for it to thrive. It's important to realize that vision and focus are deeply linked through what's called top-down processing. When you decide to look at something on purpose, that choice is initiated by your prefrontal cortex, the brain's executive center. It sends signals down to the visual cortex, telling it what to prioritize. This top-down control is essential for tuning your focus, and visual anchoring strengthens this process. It acts like a warm-up for your prefrontal systems, preparing them for more complex focus tasks like writing, reading, deep work, or problem solving. Just 30 to 60 seconds of visual anchoring, especially when done consistently at the same time each day, begins to teach your brain how to transition from a reactive state to a focused state. You're not waiting for focus to randomly appear, you're training your system to generate it on demand. And like all neural habits, the consistency of the behavior is more important than intensity. Even if it feels awkward or too simple at first, the effects compound over time. Incorporating visual anchoring before any cognitively demanding task, studying, working, planning, or even difficult conversations can act as a neural primer. It tells your nervous system that it's time to downregulate distractions and upregulate attention. You're not hoping to focus, you're creating the neural conditions for focus to emerge. Focus is not just a state of mind, it's a specific configuration of neural activity that begins in the prefrontal cortex, a region of the brain located right behind your forehead. Often described as the command center for higher order thinking, this part of the brain plays a critical role in goal-directed behavior, decision-making, attention control, and the inhibition of distractions. When you're deeply focused on a task, whether it's reading, writing, or solving a problem, the prefrontal cortex is in a state of high activation, managing the flow of information between your thoughts and your actions. The prefrontal cortex doesn't work alone, though. It interacts with a network of other brain regions, including the parietal lobe, which is involved in sensory integration, and the basal ganglia, which regulates habit formation and motor control. But the unique power of the prefrontal cortex lies in its ability to prioritize one task over another. It's the brain's way of saying, this matters right now, everything else can wait. This prioritization is essential for relentless focus. It enables you to stay with a task longer, ignore irrelevant inputs, and return to your work even when you feel the pull of distraction. For the prefrontal cortex to function optimally, it requires the right neuromodulatory environment, meaning it needs to be supported by chemical messengers like dopamine, norepinephrine, and acetyl. These neurochemicals act like volume knobs, amplifying or reducing the activity in specific circuits depending on your internal state and external demands. When dopamine levels are balanced, for instance, your ability to hold attention and resist impulses improves. when norepinephrine is released in moderate amounts. It helps sharpen mental alertness and enhance the signal-to-noise ratio in your brain. Acetylcholine, on the other hand, is associated with learning and sustained attention, making it easier to stay engaged with a single objective for long periods. The way to access this chemical support isn't through luck or random bursts of motivation, it's through behaviors that signal the prefrontal cortex to take charge. This includes intentional practices like visual anchoring, breath regulation, and single hugging. Each of these behaviors creates the physiological and psychological conditions for prefrontal activation. When you perform them consistently, your brain learns to shift into a state of controlled focus more easily. Over time, you're not just relying on willpower, you're creating a brain that is biologically better at maintaining attention. One of the major obstacles to focus is the amygdala, the brain's threat detection system. When you're under stress or feeling overwhelmed, the amygdala sends alarm signals that hijack the prefrontal cortex. This is why focus collapses when you're anxious. The brain diverts resources from thinking and planning to defense and survival. That's why it's essential to manage your physiological state before trying to engage in deep focus. Practices that lower your stress response, like box breathing, posture control, or exposure to natural light, indirectly support the prefrontal cortex by quieting the amygdala's influence. There's also a concept in neuroscience called working memory, which is the ability to hold and manipulate information in your mind over short periods of time. This function is also governed by the prefrontal cortex. When you train your focus, you're also improving your working memory, which in turn makes it easier to stay on task. It's a virtuous cycle. Better focus strengthens working memory, and stronger working memory supports better focus. This interplay creates a foundation for cognitive resilience, the ability to stay mentally present and productive even in high stimulation environments. Importantly, the prefrontal cortex is one of the last regions of the brain to fully develop, and it's also one of the most flexible. This means it's highly responsive to training and environmental input. If you repeatedly engage in behaviors that support focused attention, you're reinforcing the neural architecture of this region. You're teaching your brain to become better at what it practices, and with enough repetition, those changes become more permanent through the process of synaptic plasticity, where neurons that fire together begin to wire together more efficiently. Focus isn't just a mental decision, it's a biochemical experience orchestrated by the brain's reward system, and at the center of that system is a powerful molecule called dopamine. Dopamine is not merely the pleasure chemical as it's often described. It's more accurately understood as a molecule that signals motivation, anticipation, and reinforcement. It's the reason you feel driven to pursue certain goals and ignore others. And when it comes to cultivating relentless focus, dopamine plays a pivotal role in shaping your brain's behavior over time. Every time you focus deeply on a task, especially one that is goal-directed, your brain releases a small amount of dopamine. This release doesn't just feel good, it acts as a feedback signal. The brain interprets it as, this thing I'm doing right now is meaningful, keep going. That's the essence of the dopamine feedback loop. The more you focus, the more dopamine is released. And the more dopamine is released, the easier it becomes to focus again in the future. This loop is what turns short moments of concentration into long-term neural wiring. The dopamine system is highly sensitive to how you approach your tasks. If you constantly multitask, shift between screens, or allow yourself to be interrupted, your dopamine system becomes confused. Instead of reinforcing deep, sustained effort, it starts to reinforce shallow, fragmented attention. That's because your brain doesn't distinguish between meaningful and meaningless engagement. It only responds to novelty and stimulation. So if you reward yourself with quick hits of dopamine through checking notifications, scrolling, or jumping from one tab to another, your brain begins to associate those scattered behaviors with reward. Over time, it becomes harder to focus, not because your willpower is weak, but because your dopamine system has been trained to expect frequent novelty instead of sustained effort. To reverse this trend and rewire your brain for deep focus, you have to consciously align your dopamine release with unitasking, engaging with a single goal-oriented activity without Distraction. This means setting clear intentions, creating friction against interruptions, and deliberately celebrating small milestones. For instance, after completing a 25-minute work sprint, acknowledge the effort, not the outcome. That recognition, either spoken aloud or felt internally, triggers another small pulse of dopamine, reinforcing the behavior. One of the most effective ways to enhance the dopamine focus loop is through a process called self-generated reward. This is when you cultivate a mindset that takes satisfaction in the act of focusing itself, regardless of external validation. By internalizing the value of concentrated effort, feeling good about being locked in, regardless of whether you finish the task, you condition your brain to seek focus for its own sake. This is an incredibly powerful lever because it means you no longer depend on external rewards to sustain your attention. There's also a timing component to this system. Dopamine is not meant to be constantly high. Instead, it functions best when it rises in response to effort, peaks with goal achievement, and then drops to baseline. When you structure your workflow in intervals, periods of intense focus, followed by intentional rest, you create a natural rise and fall in dopamine levels that matches your brain's biological rhythm. This keeps the dopamine receptor sensitive and prevents burnout or overstimulation. Interestingly, some of the most effective focus rituals actually begin before you start working. Just preparing your environment, removing digital clutter, setting a timer, visually anchoring your gaze can prime the brain for dopamine release. Your brain anticipates reward, and that anticipation itself boosts motivation. This is what neuroscientists refer to as dopaminergic priming. It's why rituals matter. They send a signal to your nervous system that something important is about to happen, and that signal triggers the biological cascade necessary for peak attention. Your ability to focus is essentially your ability to manage your dopamine system. When you consistently link focused effort to a sense of internal reward, you're strengthening the neural pathways that make future focus easier. The behavior reinforces itself. Each time you resist distraction and lean into sustained effort, you're teaching your brain that this is valuable, that it's worth repeating, and that clarity, momentum, and performance lie on the other side of that commitment. The brain is not a fixed machine. It is a highly adaptable plastic system that constantly reshapes itself in response to what you repeatedly do. This adaptability, what neuroscientists call neuroplasticity, is the biological foundation of all learning, habit formation, and personal change. If you want to develop relentless focus, it's not enough to simply understand the concept intellectually. You need to implement it daily because repetition is the signal your brain uses to decide what matters. Daily implementation is what tells your nervous system this behavior is a priority. Strengthen the circuits that support it. Neuroplasticity operates by reinforcing neural pathways that are used frequently and pruning away those that are neglected. Every time you engage in a moment of deep focus, you are activating a specific network of neurons, most notably in the prefrontal cortex, parietal cortex, and basal ganglia. When these networks fire together consistently over time, they begin to wire together more efficiently. The connections become stronger, faster, and more automatic. What was once effortful becomes easier, even instinctual. This is how focus transitions from something you chase to something you embody. But the key is consistency. The brain doesn't respond to occasional effort. It doesn't rewire itself based on what you do once in a while. It rewires based on what you do every day, even if the effort is small. This is why a daily focus habit, even as simple as 1 or 2 minutes of visual anchoring, breath regulation, or distraction-free work, can have disproportionate effects over time. These short, repeated signals accumulate, they compound, they change the structure of your brain. What's often misunderstood about neuroplasticity is that it's not just about learning new things. It's also about unlearning old patterns. If you've trained your brain to seek stimulation every few seconds through multitasking, notifications, or compulsive checking, those behaviors have already shaped your neural architecture. Your focus isn't broken, It's just been trained in the wrong direction. To reverse that, you have to teach your brain a new normal. You do this through daily behaviors that reward stillness, presence, and sustained attention. This rewiring process involves two phases. The first is activation, doing the habit and engaging the neural circuits. The second is consolidation, allowing those circuits to stabilize and become the default. Consolidation happens during sleep, especially deep sleep, when the brain replays patterns of neural activity that occurred during the day. This is why recovery is just as important as the practice itself. Without sufficient sleep and downtime, the brain can't encode the changes you're working so hard to build. One of the most effective strategies for daily focus training is habit stacking. This involves pairing your new behavior, like 60 seconds of visual anchoring or a short focus session, with an already established routine. For example, right after brushing your teeth in the morning, you can sit down and stare at a fixed point on the wall for 1 minute, calming your visual system. Or before opening your laptop, you can take 3 deep nasal breaths while looking at a single object in your space. These small rituals send a consistent signal to your brain. It's time to shift into a focused state. Over time, the brain begins to associate those cues with high cognitive performance. Another powerful reinforcement tool is tracking. When you track your focus behaviors, whether through a notebook, app, or mental check-in, you bring awareness to the process. You become more intentional. And intention is what amplifies neuroplasticity. The more deliberate you are about the behavior, the stronger the signal your brain receives. Focus is not a passive trait, it is an active practice. And by tracking it daily, you turn the invisible process of brain change into something tangible. The good news is that focus doesn't require perfection, it requires repetition. You don't need to eliminate all distractions forever or become a monk-like master of attention overnight. What you need is to show up for the practice every day, even if only for a few minutes. Each time you engage in a behavior that supports deep focus, you're investing in the neural circuitry that will eventually make that state easier to access, more natural, and more resilient to stress, fatigue, and distraction.